Hi, welcome back to another video with Miss Curdy. Today we're going to be talking about 2-2, 9 as a factor. And this is the factor that seems to be the trickiest for most people. So I'm going to show you three options, three different ways that we can solve problems that have 9 as a factor. And once you know all three, you can start choosing the one that works best for you. Whenever you have 9 as a factor, I always recommend looking at both factors to decide which factor is the easiest one to use one of our strategies with. If you had a 2 times a 9 or a 5 times a 9 or even a 10 times a 9, you would definitely use the strategies that go along with those other factors as they are the most efficient and probably the easiest. But there are some cases where the 9 might be your best option, so let's take a look at some ways to think about it. The first way is to use the distributive property to solve these equations. So for example, if I had a problem like 9 times 9 and I wanted to use the distributive property, I would think about my 9 and what I can break it up into. And that 9 can be broken up into a 5 and a 4. Both of those are pretty easy factors to work with. So when I go to put it in my equation, I know my 8's not going to change, it will stay the same, and that my 9 is now a 5 and a 4. When I skip count 5 times 8, I will get a 40. And then when I use my strategy for my 4's, I would think double, double. 8 doubled is 16. 16 doubled is 32. So now it comes down to adding 40 plus 32. And if I want to use my standard algorithm, I get the answer of 72. So that way I know 9 times 8 is 72. Another strategy, another way to think of this is to think of that 9. Instead of a 9, think of it as 10 as a factor, because we know that's a very easy factor to work with. We just annex on that 0. So here I can think of 9 times 8. Instead of thinking of it as 9 times 8, I can think of it as 10 times 8. And at the end, I know I have one extra group, so I'm just going to subtract that factor one time. So here I've got 9 times 8. I'm going to think of it as 10 times 8, which is 80. And then I subtract 1, 8 to get 72. Let's try that strategy two different ways. So when I'm doing 9 times 7, I can think of it as 10 times 7 equals 70, minus 1, 7 to give me 63. And that step might take a little time to think about, but again, we think of it as a 10 times 7 and then minus one of those groups. 9 times 6, I can think of as 10 times 6, which would give me 60. And then I would subtract a 6 to get a 54. So 9 times 6 is 54, and 9 times 7 is 63. Recap, we can use the distributive property to solve this, or we can think of our 9's facts as thinking about it as 10 groups, and then we subtract 1. And whatever is that other factor is what you subtract. So 9 times 8 would be 10 times 8 minus 8. 9 times 7 would be 10 times 7 minus 7. And 9 times 6 can be thought of as 10 times 6 minus 6. All right, and there's one last strategy, and this is pretty cool the way it works out, but it is pretty tricky to do, especially when we first get started. So we can use a pattern. When you look at the chart over here, you may notice something. And what's really cool is that as you look at the pattern, you'll notice that the tens digit is 1 less than the factor that you're multiplying by. And then the ones digits, when you add the 10 and the ones, it actually equals 9. So let's zoom in and take a look at what happens with our products of our 9's. So take a peek. I'm just going to focus this so we can see it better. As we go through, we've got 9, 18, 27, 36, 45, 54, and 63. One thing we might notice is that our tens digit is going up by 1 every time, and our ones digit actually drops by 1 each time. And when you look at the two digits and you add them together, they actually equal 9. 8 plus 1 is 9, 7 plus 2 is 9, 6 and 3 is 9, 5 and 4 is 9, 4 and 5 is 9, 6 and 3 is 9 again. So if this pattern were going to continue, I know my my tens digit goes up by 1 and my ones digit goes down. So 8 times 9 is actually 72. And the next one, my tens goes up by 1 and my ones goes down by 1, giving me 81. And when you add those digits together, 7 plus 2 also equals 9, and 8 plus 1 equals 9. That's a really cool chart to use. However, if you were trying to solve 8 times 9, you wouldn't want to go and fill out this whole chart from scratch each time. So let's take a look at how we can do it by looking at the equations. So whenever we have our 9's facts, we can look at that other factor and we think, what is 1 less than that digit, which would be a 7. And then we think of that as our tens digit, and then we can think 7 plus what would give us 9, and the answer to that question would be 2. So our product would be 72. Let's take a look at it again. So when I'm doing 9 times 7, I'm going to look at that 7 and say, what is 1 less than 7? And that would be a 6. And then I can think 6 plus what equals 9. And our answer there would be a 3. So my answer is 63. Let's try it again with another problem. Let's try 9 times 6. And give yourself a chance to try this out looking at both of these examples here, and pause the video and try to solve this one on your own, and then meet me back to walk through it to see how you did. All right, let's take a look. So when I'm solving this, I'm going to think, what is 1 less than 6? And the answer to that is, of course, 5. And then I want to think 5 plus what is going to give me 9? And I know that that is going to be 4. So my answer is going to be 54. It's a really cool strategy once you get the hang of it. But you now have 3 options when solving your 9's facts. Again, keep in mind, only use these strategies when necessary. 9 is the trickiest factor. And whenever possible, look at your other factors to see which one would be, which is the best strategy for you. Once again, thanks for joining me, and that is lesson 2-2, 9 as a factor. And I hope you have a really great day, and join me back for our next video.